So now we see about the hybridization. So how to know the hybridization in different molecules. So to know the hybridization of a central atom in a molecule, so we have a method. So in which we calculated steric number with help of steric number of a central atom. So by knowing the steric number of central atom, we are able to know the hybridization of that molecule. So why are just calculating the central atom steric number means we know the only central atom undergoes hybridization. In any molecule, central atoms only undergoes hybridization. That's why we are calculating steric number of central atom. So what is meant by steric number? So see, the steric number is steric number of a central atom in a molecule is number of sigma bonds of it, and plus number of lone pair of electrons, number of lone pair of electrons on it. So that is known as steric number of that atom. So if I am taking the steric number as this Sn, if the steric number is 2, means on this calculation if you got 2, that indicates sp hybridization. Here we will get 2 s1 p1, total we will get 2 orbitals. If steric number is 3, that indicates sp2 hybridization, means there is a 3 number, s is 1, here 2, total 2 plus 1 3. If you got steric number 3, so directly we can conclude that it undergoes sp2 hybridization. In the same way, if steric number is 4, sp3, if steric number is 5, sp3d, if steric number is 6, that is sp3d2, if steric number is 7, that is sp3d3. So these are this is the method to do the hybridization of a central atom in a molecule. Now we discuss this by taking some examples. Okay. Now I am taking a simple example. Methane. So what is the central atom in methane? Carbon is the central atom. In methane, whether the carbon belongs to 14th group, nothing but 4th A group. It is having 4 valency electrons and it has bonds with 4 hydrogens separately. Means there is a 4 sigma bonds around the carbon. So what is the steric number of this carbon? To follow this formula, the number of sigma bonds of it. So this carbon is having how many sigma bonds? 1, 2, 3, 4. 4 sigma bonds. So how many lone pairs are in it? Number of lone pairs on carbon, there is no number of lone pairs. That is equal to 4. So if you get steric number 4, that undergoes sp3 hybridization. Means the hybridization of carbon in CH4 is sp3. Okay, now we see the more examples. Okay. Now see the more examples. Take the other example. So ammonia. So what is the central atom? Nitrogen is the central atom. It belongs to 15th group. It is having 5 valence electrons. It forms 3 bonds with hydrogens and the 2 valence electrons exist as lone pair of electrons. So here we are not writing the exact structure here, just we are calculating the hybridization of nitrogen. So what is the steric number here? It is having 3 sigma bonds it, and is having one lone pair of electron, total you got 4. So it is having sp3 hybridization. When nitrogen undergoes sp3 hybridization in ammonia. So now we see some more examples. H2O. So what is the central atom in H2O? So oxygen is the central atom. So it has valence electrons 6. So it is having, there is 6 electrons, 1, 2, 3, 4, 5, 6. And it is bonded with 2 hydrogens. Means what is the position of hydrogen? Nothing but what is the steric number of that oxygens? It is having 2 sigma bonds. This is 1, this is 2. 2 sigma bonds and 2 lone pairs. Steric number 4. So it is the oxygen undergoes sp3 hybridization. Let's see some more examples. So beryllium chloride. So beryllium is belongs to second A group. It is having 2 valence electrons bonded with 2 chlorines. So what is the steric number of beryllium? Here steric number of beryllium is it is having 2 sigma bonds. It is having no lone pairs on it. If steric number is 2, that indicates sp hybridization. And if you see PCl5. So what is the valency of phosphorus? The number of valency electrons in the phosphorus is 5. So there is a 5 chlorines are present. We are not writing exactly structure, just we are calculating the hybridization. So we can write in any direction. So what is the steric number of phosphorus? The steric number of phosphorus, the number of sigma bonds are 5, and there is no lone pairs or exist on the phosphorus. So 5. So it undergoes sp3d hybridization. Okay, take another example, SF6. When the sulfur belongs to 16th group, or nothing but we can say it is the 60th group, having 6 valency electrons. It is bonded with 6 fluorines. So what is the steric factor? Nothing but steric number of sulfur is the number of sigma bonds. How many? 3, 4, 5, 6, 6, and there is no lone pairs on the sulfur. That gives sp3d2 hybridization. So 6 means just way to remember with S1, P3, 3 plus 1, 4, 5, 6. 6 indicates the sp3d hybridization. Okay. For example, take IF7. We know the iodine belongs to 17th group, or nothing but we can say it is the 7th A group having 7 valency electrons. So iodine 1, 2, 3, 4, 5, 6, 7. So it is bonded with the 7 fluorines with the single bonds to all of them. So what is the steric number of iodine here? 1, 2, 3, 4, 5, 6, 7 sigma bonds. There is no lone pairs on the iodine, so it is equal 7. We will get sp3d2. S1 3 plus 1 4 5 6. It must be 7, so it undergoes sp3d3 hybridization. So this is the general method to calculate the, nothing but to identify the hybridization in a normal molecules. Okay.